1.10 is on higher order polynomial functions. First of all, we're looking at some definitions here. A polynomial may be written in either factored form or expanded form. We're probably used to saying them in expanded form. They can be given to us in factored form as well, or if we had it expanded, we could factor it ourselves. It's possible to go from one form to the other, and vice versa. So my goals here is to write in expanded form, decreasing order, then determine degree and leading coefficient. All right. So first, this one is already in expanded order, but it's not in descending order, decreasing order. So my leading term would be the 8x to the 5th. Next term would be the x to the 4th, then the 4x cubed, then the minus 2x. Just getting it in descending order there. Once it's in descending order, we can determine the degree and leading coefficient from the term with highest power. So the degree is 5 and the leading coefficient is 8. All right. In the next one, it's currently in factored form, so I need to multiply it out to get it in expanded form. Unfortunately, I can't multiply all three of those out at the same time. I need to do 2 at a time. So let's multiply those out. First, that gives me x squared plus 2x minus 6x minus 12. Then I got to multiply by the x plus 4. Let's combine like terms first. That's x squared minus 4x minus 12 times x plus 4. Then we will distribute again all 3 parts in the first one into the second one now. So that would be x squared times x is x cubed plus 4x squared, then minus 4x squared, then minus 16x, last minus 12x, and minus 48 there, 12 times 4. Okay. Hopefully I got all my signs right. So that's positive, positive, negative, 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 negative. That's good. Okay, so x cubed, the x squared actually add 0. Then I have negative 28x. Then I have minus 48. Okay, so leading term, highest power, got it in the front already, so I'm already in decreasing order. So the degree is 3 and leading coefficient is 1. Invisible 1 right there for leading coefficient. Okay, this is also in factored form, so I'm going to expand it, and then we'll be able to find leading coefficient in the degree. Okay, so distribute, 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 distribute. Leave that x out there for later. X squared times 3x is 3x to the 3rd minus x squared plus 15x and then minus 5. Distribute that x now. That would be 3x to the 4th minus x to the 3rd plus 15x squared minus 5x. Leading term is the 3x to the 4th. Its degree is 4 and its leading coefficient is 3. Okay. On the next page, we have some investigation. In a classroom, you would be given a few minutes to try this. What your goal is to find 2 binomials that can be multiplied together so that the result is a polynomial with 2 terms, 3 terms, and 4 terms. Just kind of observing from the previous page, here we multiplied 3 different binomials together. Because those canceled, we only had 3 terms left. We might have expected 4 terms there. So if you want to pause the video, give that a try. When you unpause, I'll just give you a few examples, although there are many, many answers here. Okay. Now, my goal is actually only to get 2 binomials, so I'm not doing 3 at a time. Multiply them together to get 2 terms. If I want 2 terms, when I multiply 2 binomials together, if I look back again, if I multiply just 2 binomials together, normally I'm going to get 3 terms. The only way to get 2 terms is to have something cancel out. So part A, I could multiply, say, x plus 2 times x minus 2. That's going to give me x squared minus 2x plus 2x minus 4 gives me x squared minus 4. So if I use the difference of squares, I can if I multiply binomial conjugates together to get my difference of squares, which has just 2 terms. Okay. 3 terms, I just don't want cancellation. So I get like x plus 1 times x plus 2, where I don't get cancellation. I get x squared plus 2x plus x plus 2, for example. So x squared plus 3x plus 2. So those 2 cases are probably the most familiar. And then if I want to get 4 terms, we kind of saw how we could get that down here when we had one power already higher in one than the other. Nothing was like, so I was able to get 4 terms. So that's another way to get 4 terms. So we could have something like x squared plus 1 times x plus 2, and that will give us x cubed plus 2x plus x plus, 2x squared, right there, then x plus 2. Okay, that would be how I get 4 terms. All right. Now let's check out factoring higher order polynomials. We've already discussed factoring quadratics. Many of the same techniques are going to come into play. You always want to look for a GCF before you do anything else. And then it's going to just depend on how many terms you have, what your strategy is going to be. Okay, if you have 4 terms, you're going to try grouping. And so this first one does not have a GCF, but it does have 4 terms. So I want to group. And so when I group them, I'm looking at factoring the first 2 with each other and factoring the last 2 with each other. The first 2 have an x squared in common. So x squared out leaves me with x plus 5. Minus the second 2 have 4 in common, divide negative 4 out, leaves me with x plus 5. You better have the same binomial if you're going to keep factoring by grouping. So x plus 5 is in common. When you pull that out, the first term leaves you with x squared minus 4 from the second term. Now, that's been factored, but it's not factored completely because you have a difference of squares right here. So you can factor that again into x plus 5 times x plus 2 times x minus 2. Now it's been factored completely. So you want to factor until you don't have any factorable quadratics left. All right. Let's try that technique again in part B. But first, I think I have a GCF of 3 and x. So we'll take our GCFs out first if we have them. So it'll leave me with 2x cubed plus x squared plus 8x plus 4. And now we can group the first 2 and the last 2. So that's 3x, big bracket right there. Just x squared is in common. Leaves me with 2x plus 1. Plus 4 is in common. Leaves me with 2x plus 1. So that's 3x times the 2x plus 1's come out. And x squared plus 4 this time is left. Unlike x squared minus 4, x squared plus 4 is prime, so that cannot be factored any further. That's now done. Okay. Okay, so quadratic form. This is another type of factoring. Instead of factoring by grouping, we're going to factor things that are like quadratics. So they are something of the form. Remember that a quadratic would be ax squared plus bx plus c. This might not be an x squared, but it might be so ax squared plus bx plus c. What if you had x to the n in your middle term, and x squared would be that squared, so you would have 2n in your last term, first term, I meant to say. So you just need to have twice as many x's in your leading term as you do in your center term to be quadratic-like. Because, just as another note right here, because x to the n squared, powers multiply, is x to the 2n, right? So that's the idea about this being quadratic-like. It's going to factor the same way. Okay? So a substitution is optional. I'll walk through it once with a substitution, once without. Personally, I don't like to write it, but some students really do. So I'm going to do both ways. So this is quadratic-like because I know that x cubed squared, or times 2, power times 2 squares it, is x to the 6th. So I can factor this with x cubed in the first position. I just need to find now two numbers multiplied to 18 that add to 11. So if I break down my 18, 2 and 9, right? Add to 11, so I can do plus 2 and plus 9. And now we're factored. Okay. If you'd like to see it with substitution, it would look like let u equal x cubed, then u squared equals x to the 6th. So you could rewrite this as u squared plus 11 u plus 18. You're just rewriting in terms of a quadratic. You can get down to the u plus 2, u plus 9, and then replace u back with x cubed plus 2 and x cubed plus 9. Okay. Some people like to write it that way because it becomes regular quadratic, which is more traditional to factor. So if you're more comfortable with this, you may definitely do the substitution if it makes you happy. Okay, the next one is also quadratic-like because when you square the center term, you get the first, right? When you square x squared, you get x to the 4th. Okay. This one's not a equals 1, so I'm going to use grouping. So we're going to do AC method, for grouping. So I'm going to start with 4 times 9, which is a times c. 4 times negative 9, or a times c, which is negative 36. We're going to break that down. Positive, negative with a larger negative to get that negative 35. Negative 36 and a positive 1. We'll do that. And then we're going to reorder in groups. We have 4x to the 4th minus 36x squared plus x squared minus 9. Now we're doing GCFs, first 2 terms, last 2 terms. Since we have 4 terms now, we're grouping. 4x squared in common leaves you with x squared minus 9 plus nothing in common, just 1, leaves you with x squared minus 9. The x squared minus 9s are in common, factor those out. The 4x squared plus 1, not in common, those are the leftover pieces. Okay. Difference of squares, you can factor that first one further. X plus 3, x minus 3. Sum of squares prime, so the 4x squared plus 1 stays. If that would have been a minus 1, we would have been able to factor further, right? But it wasn't. All right, so that's factored. Okay, that's the end of part 1. We'll do another one for part 2.